This is mathheals.com if you want to find more links to YouTube math videos. Let's take a look at asymptotes. And let's look at our first problem, assuming I had my tablet up. Let me bring it up. Get my pen to work here. Hello? Hello? That's interesting. Oh. There we go. It's a cheap tablet, but $100 it works pretty good. Okay, so we're given f of x is equal to x plus 2 over x squared minus 7x. And they're asking us to determine all the vertical asymptotes of the graph of the function. Now, if you remember from college algebra, an asymptote is an invisible line your graph will skim at some point. Vertical, of course, means up and down. Let's take a look at finding a vertical asymptote. So, finding vertical asymptotes. Step 1. Factor the top, factor the bottom. So in this particular problem here, top part doesn't factor. The bottom part, though, is GCF. They have an x in common. So I can factor out an x, and that gives us x minus 7. Step 2, cancel if possible. Well, here we have x plus 2. This would have to be an x plus 2 down here for us to cancel. So they have to be exact. So we can't do that. Step 3. Set the denominator equal to 0. Then solve. So I set x times x minus 7 equal to 0. Now the zero factor property from college algebra says if you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x equal to 0, and I'll set x minus 7 equal to 0. So this is 0. And if I take negative 7 over, it becomes a positive 7. And these are our vertical asymptotes. Now let's go graph this. They're not asking us to, but I just want to do it to really emphasize what is a vertical asymptote. Because the best way is to look at the graph. Now the key to graphing these is to put parentheses around top, parentheses around the bottom when you plug in your calculator. So I'll put parentheses around top and parentheses around the bottom. Now you only have to do that if you got more than a single variable or a single number. So let's see what we get. So press y equals, press clear. I'll do a beginning parentheses, x plus 2, close parentheses, divided by, beginning parentheses, x squared minus 7x, close parentheses. And press graph. Now if your calculator doesn't look like this, press zoom and choose Z standard. I think it's 5 or 6. Now we said that we had a vertical asymptote of 0 and 7. If I come over here to 7, there's a invisible line here the graph is skimming. It's getting real close to it, but never touching it, never crossing it. That's actually, we're going to see a study of a limit. You're studying it as it goes forever, for example, or as you get closer and closer to a number. So in some cases we'll look at x as it goes to infinity, and maybe some cases we'll look as x goes to 7 from like the left hand side. So you're studying what's it doing. Well, here at 0, you see how this graph just stops? They never just stop. This goes forever down. It just got so close to the y-axis it's now looking like 1 with it. And this right up here stops. So it's actually going up forever also. So again, that's a vertical asymptote. Now in a T83, the all black calculator, you'll actually have a vertical line there That's not supposed to be there. That's a flaw with the calculator. Let's look at our next problem. We got f of x is equal to x squared minus 12x plus 32 over x squared minus 16. Step 1. Factor the top, factor the bottom. We're finding the vertical asymptote again. This is the PSD method, and this is dots, difference two squares. This top part factors as x minus 8 times x minus 4, and the bottom part factors as x plus 4 times x minus 4. Step 2, cancel if possible. Well, they both have an x minus 4, so x minus 4 is going to cancel. And we got x minus 8 over x plus 4. Step 3, set your denominator equal to 0 and solve. So we got x plus 4 is equal to 0, and we get x is equal to negative 4. And that's our vertical asymptotes. Now just for fun, let's graph it, see what it looks like. So parentheses are on top, parentheses are on the bottom when we plug it in. I'll press y equals, clear, beginning parentheses, x squared minus 12x plus 32, closing parentheses on top, divided by beginning parentheses on the bottom, x squared minus 16. And then closing parentheses on the bottom. And then graph. We said there's a vertical asymptote of negative 4, and if you see 1, 2, 3, negative 4, it does look like that. These will eventually get closer and closer to it, skim it, but never touch it, never cross it. This will get closer and closer to it, but skim it, but never touch it or cross it. Now, if I looked at my domain up here, our domain, if I were to set the denominator equal to 0, I'd get x squared minus 16 equal to 0. And I can take negative 16 to the right side, it becomes a positive 16, drop a squared, and put a plus or minus square root around the other side. That would give us x is equal to plus or minus 4. These are the values we cannot plug in there. So this is our domain is x cannot equal to these values. Well, what does that mean in terms of our graph? At negative 4, we've already said we got a vertical asymptotes, like that. And here's our graph, like that. And then the graph up here is going something like that. Okay. Here at 4, we said that our domain says it doesn't exist there. What we're going to find at 4, we have an open hole in our graph. So we have a hole. So something to keep in mind. Your vertical asymptote and your domain will not always match. This right here is actually the invisible line, or vertical asymptote, and the other one's a hole. Let's look at our third example. The limit as x goes to 3, looks like a minus power, 1 over x minus 3. Now if you remember these from earlier on when we covered limits, this negative, what looks like the negative power, that says from the left hand side. Now the instructions here say use a graphing utility to find the limit. So we're studying the limit as x approaches 3 from the left hand side. Obviously if I put 3 in here, 3 minus 3 give me a 0 in the denominator. Well, let's go graph this. Remember the key is if you got more than a single number or a single variable on top or bottom, you have to put parentheses around it. So when we plug this in, we're going to need to put parentheses around the x minus 3. So I'll do y equals, clear, 1 divided by, beginning parentheses, x minus 3. Closing parentheses, and then graph. Okay, from the left-hand side, here's 3. I'm coming from left-hand side. It's like I'm tracing the graph. Look at what my y values are doing. My y values are going down forever. So down forever is negative infinity. You could actually, even if you wanted to, actually press trace on your calculator. And see, this is where my cursor is. So as I press my right arrow key, you see it's getting closer and closer to x equals 3. And, well, it's I couldn't see very much of it. It flipped up there too fast. But anyway, when it got to this, you see y was negative 46. So it's going down forever. Now these are more of actually just studying where's it headed toward. Like this is going to negative infinity. Let's look at this next one. The limit as x goes to 4, what looks like a plus power, 2x plus 1 over x minus 4. Well, this is what looks like the plus power. That means from the right-hand side. So we're studying the limit as x goes to 4 from the right-hand side of 2x plus 1 over x minus 4. Now the key is, if you have more than a single number, single variable, again, you have to put parentheses around it when you plug in your calculator. So put parentheses around the top, parentheses around the bottom. And let's see what we get. Press y equals, clear. Actually, let me clear up my history there. Y equals, clear. Beginning parentheses on top, 2x plus 1. So 2x plus 1. Closing parentheses divided by beginning parentheses x minus 4. Closing parentheses and then graph. Okay, so we're studying the graph as x approaches 4 from the right-hand side. Okay, here's 4. Coming from the right-hand side, I'm getting closer and closer, tracing the graph. I'm getting closer and closer to the x equals 4, that is. And I see the y values are going up forever. So this is going to equal to positive infinity. Number 5. Let's look at this one. The limit. Now those demonstrated the vertical asymptotes. You know that, like here, 3 would be our vertical asymptote, and here 4 would be our vertical asymptote. Now let's take a look at this one, see what it's demonstrating. Limit as x goes to infinity of 2 plus, well actually I'm sorry, this is the next type. This just says find the limit, doesn't say use your graphing utility. Now infinity, well one method we have is just go ahead and plug that in for x. So I got 2 plus 4 over infinity. Well, let me think of if I had like 1 over 1. That's equal to 1. If I had 1 over 10, that's equal to 0.1. 1 over 100 is equal to 0.01. As the numbers get larger, this keeps getting smaller and smaller. So as this goes to infinity, this keeps getting smaller and smaller, so this is approaching 0. So anytime you have infinity on the bottom, like you got 1 over infinity or 4 over infinity, that's going to be equal to 0. So this is 2 plus 0 or 2. So that's our answer. Now, if we looked at this graph-wise, what we'd find is that this is a horizontal asymptote. Let me save this. Though they're not asking us to look at it graphically. Let's see. Asymptotes. Page 01.pdf. There we go. Let's look at our next problem. Limit as x goes to negative infinity of 5 plus 1 over x squared. Now, it doesn't really matter if we have 1 over infinity or 1 over negative infinity. It still goes to 0. But in this case, once we plug in negative infinity, we've got 5 plus 1 over negative infinity squared. Well, when you square anything, it becomes positive. That'd be 1 over infinity squared. Now, 1 over infinity goes to 0. If you got an infinity squared, that even goes to 0 even faster. So this is going to equal to 5. Now, the next ones talk about the horizontal asymptote. And these here at first talk about the college algebra way to do it. Now remember, if we got a fraction, we got our top of our fraction, our numerator, and we got our bottom of our fraction, our denominator. Our degree is our largest power of x. So keep all those in mind. And we got a horizontal asymptotes. Okay, I have case 1. The degree of the top is larger. So the degree of the top is larger. For your horizontal asymptote, there would be none. Case 2, the degree of the bottom is larger. For your horizontal asymptote, you'd have y is equal to 0. And case 3, degrees are the same. So the degree of the top is equal to the degree of the bottom. Now I like to show this with an example. I think it's best shown that way. So I got 4x to the third minus 2 over 7x minus 9x to the third. It's a very easy concept. Yeah, the degree of the top of this example is 3, degree of the bottom is 3, so the degrees are the same. We take the number off the front of the x to the largest power. Like this is 4, and this one is negative 9. And I create a fraction out of them. Again, I take the number off the front of the x to the largest power and create a fraction out of them. Now, it's a very simple concept, but when I start writing down standard form and leading term and coefficient and so forth, it gets confusing for students. It's a very simple idea. Well, let's take a look at some problems. Got f of x is equal to 8x plus 2 over 4x minus 3. Instructions say find the horizontal asymptote. Well, the degree of the top is 1, degree of the bottom is 1. So it's case 3. Degrees are the same. Well, we're going to create a fraction. Take the number off the front of the x to the largest power. So we'll have 8 over 4, or y is equal to 2. See number 8. F of x is equal to 3x over x squared minus 1. Degree of the top is 1. Degree of the top is 1. Degree of the top is 2. So the degree of the bottom is larger. That's case 2. Y equals 0 is a horizontal asymptote. And number 9 here. F of x is equal to x to the third minus 5x plus 2 over x squared plus 4x minus 2. Degree of the top is 3, degree of the bottom is 2. This is case 1. Degree of the top is larger. There is no horizontal asymptote. Okay. Now you learn those in college algebra, and you probably lose sleep. Like, well, why are those true? You know, why are those 3 cases? I'm being sarcastic there. Well, let's take a look at why does that work. Okay, so we got limit as x goes to infinity of x squared plus 3 over x to the third minus 1. Well, if I plug in the infinity, we'd have infinity squared over infinity to the third, and you can't treat infinity like a normal number. I mean, we will plug in certain cases, but you can't think, well, what does infinity squared mean? Is that infinity? Infinity cubed, is that infinity? So it'd have infinity over infinity would have 1. Well, again, you can't treat it that. It's more of a concept, infinity is. Well, what we can do is we can divide everything in this fraction by x to the largest power on the bottom. Like on the bottom part here, our x to the largest power is the third. So we're going to divide everything by x to the third. So I got x squared over x to the third plus 3 over x to the third all over x to the third over x to the third minus 1 over x to the third. Well, this x squared cancels with 2 of these. We've got 1 over x plus 3 over x to the third. X to the third over x to the third is 1 minus 1 over x to the third. Okay, well now we can plug in infinity. So I'm going to have 1 over infinity plus 3 over infinity to the third power over 1 minus 1 over infinity to the third power. Okay. Now 1 over infinity is 0. Infinity cubed just goes to 0 even faster, and the 3 doesn't change anything up there. So we got 0 plus 0. And here we got 1 minus 1 over infinity cubed is again 0. So this gives us 0 over 1, which is 0. So that's what happens. The limit goes to x goes to infinity. Look up at our cases. Degree of the bottom is larger, we get y is equal to 0. The degree of the bottom is larger in this example. That's why it's always equal to 0 if you do the algebra, or calculus, sorry. Okay, 11. We get limit as x goes to infinity of x squared. And that's what we're studying. When we're studying the horizontal asymptote, we're wondering what happens as x goes to infinity, as x goes negative infinity. So we've got 2x squared minus 5. Our largest power in the denominator is x squared. So we're going to divide everything by x squared. So I got limit as x goes to infinity of x squared over x squared plus 3 over x squared, then 2x squared over x squared minus 5 over x squared. Well, x squared over x squared is 1. plus 3 over x squared. These x squareds cancel, gives me 2 minus 5 over x squared. Well, now we can plug infinity in. So we've got 1 plus 3 over infinity squared over 2 minus 5 over infinity squared. Well, the 3 over infinity squared is 0, so that's 1 plus 0. And this is 2 minus, and that's 0, which would give us 1/2. Now again, remember our rules. Here the degrees are the same, aren't they? So I create, for the horizontal asymptote, I create y equals, take the number off the front of the x to the largest power, which would be 1/2. That's why case 3 is always like it is. Number 12. Limit as x goes to infinity of 7x to the third minus 4x plus 3 over 2x squared minus 5. Again, we're going to divide everything by x to the largest power down in the denominator, which is x squared. So we're going to have 7x to the third over x squared minus 4x over x squared plus 3 over x squared all over 2x squared over x squared minus 5 over x squared. Well, 7x to the third over x squared, some of these x's will cancel, and you got 7 over, 7x, sorry. Minus, this x cancels one of these, and we've got 4 over x, plus 3 over x squared. Down here, those x squareds cancel, gives you 2, minus 5 over x squared. Well, if we plug in infinity now, we'll have 7 times infinity, minus 4 over infinity, plus 3 over infinity squared, over 2 minus 5 over infinity squared. Well, these 4 over infinity, 3 over infinity squared, 5 over infinity squared, those are all zeros, so those cancel away. And we got 7 infinity over 2, which just gives us infinity. The value we're finding here is the value that it converges to, what it finally keeps getting closer and closer to, but never touches, never crosses. This is saying infinity, so it doesn't. I mean, that's what our limit is, but that means it doesn't have a horizontal asymptote. It doesn't converge upon a value. Let me save that. Now, just for fun, let's graph maybe the number 11 and maybe number 12. So the key is put parentheses around top, parentheses around the bottom when plugging them in. So now press y equals clear, beginning parentheses, x squared plus 3, closing parentheses divided by beginning parentheses 2x squared minus 5. And then closing parentheses and then graph. Now see how this seems to be coming down here, and then just it looks like a straight line. It's just getting closer and closer to 1/2. The 1/2 here. That's a horizontal asymptote. Same on this side. Okay, let's look at this one. Let's put parentheses around top, parentheses around the bottom. Hopefully this isn't so weird it goes off the screen where we can't see it. I made these problems up. So press y equals clear. Beginning parentheses, 7x to the third. Sometimes when you make them up, they do weird things. Minus 4x plus 3. closing parentheses divided by beginning parentheses. So parentheses are on top, parentheses are on the bottom. 2x squared minus 5. Then graph. Now this just appears to be going straight down. Now we'd have to use calculus to see if that's exactly true. You know, there may be more over here. We can definitely do a zoom and choose zoom out, number 3. So press 3. And then once it comes back, press enter one time. Ah, there is more. So see, going up like that. I could possibly press enter one more time. I'm guessing it'll be garbage at that point, but let's see. Yeah, it looks like a straight line, doesn't it? But it obviously isn't converging upon some horizontal line, so it's not skimming it. Now set your calculator back by doing zoom and then choose number 6, Z standard. And did I save that? No memory, no memory. I think I did. What time is that? 4:08? Yeah, that would have been it. Let's look at our next problem as soon as I get my tablet back up and running. It tends to blow up fairly often. I'm going to grab a drink also. Okay. Let's take a look at sketching. This says sketch a graph of the equation. Number 13. Now y is equal to x minus 4 over x plus 3. And we'll be finding, use intercepts. So let's find intercepts first. And just trying to figure out the best way to do this. I guess I'll do the intercepts over here. Okay, to find the x-intercepts, you always plug 0 into the other variable. So to find the x-intercepts, we're going to plug 0 in for y. So I got 0 is equal to x minus 4 over x plus 3. Now the neat part about rationals, single fraction like this, is if you got set equal to 0, all you have to do is set the top part equal to 0. For your intercepts, anyway. And then take negative 4 over there, and we get x is equal to 4. So this is our x-intercept. Now for our y-intercept.
A vast virus database has been updated.
For our y-intercept, we'll plug 0 into the other variable, so we'll plug 0 in for x. So I got 0 minus 4 over 0 plus 3, and we get y is equal to negative 4/3. Now that's like negative 1 1/3. Sometimes that's better to have it in decimal or mixed number form. You can a lot easier see where it's crossing. Our vertical asymptotes. Now remember our steps. First step is factor top, factor the bottom. That's done. Step 2 is to cancel if possible. Well, that's done. Step 3 is to set your denominator equal to 0. And solve, and we get x is equal to negative 3. Well, let's find our horizontal asymptote. Degree of the top is 1, degree of the bottom is 1, so the degrees are the same. So our horizontal asymptote, we take the number off the front of the x to the largest power, so we'd have 1 over 1, or y is equal to 1. Okay. So that's the information we have so far. Now that's the intercepts and the asymptotes. Let's use extrema. Well, to find the extrema, we have to find the derivative. We got y is equal to x minus 4 over x plus 3. This will be p and this will be q, taking our derivative. P prime will be 1, q prime will be 1. So quotient rule, p prime q minus p q prime over q squared. So our first derivative, p prime was 1, times q, which was x plus 3, minus p, which is x minus 4, times q prime, which is 1, all over q squared. Well, 1 times anything just becomes the x plus 3. A negative out in front flips the sign of everything inside. So this becomes a negative x plus 4 over x plus 3 squared. Well, x minus x drops away. 3 plus 4 is 7 over x plus 3 squared. Okay, so that's our derivative. Now, if I were to we'll find our critical values. We set the top part equal to 0. We set the bottom part equal to 0 with a fraction. But top part, if I set that equal to 0, it doesn't go anywhere. There's no x to solve for. So I'll set the bottom part equal to 0. And we can drop the squared and just set the x plus 3 equal to 0. And we get x is equal to negative 3. So that's our critical value. So I come down to here. This is negative infinity. This is positive infinity. Remember, we want to pick our test cases. So I'll pick a value smaller than negative 3, like negative 4. Pick one larger than negative 3, like 0. And we want to plug them into our first derivative. So we want to plug those into y prime. Well, y prime is 7 over x plus 3 squared. Remember, for the increasing and decreasing and mins and maxes, we only care about the sign. Well, 7's positive, and when I square the bottom part, it's always positive. So we got positive over positive. This is automatically increasing, and this is automatically increasing, no matter what we put into it. Now, we only have mins and maxes where it changes from increasing, decreasing, or vice versa. And so this doesn't fit, obviously. Not to mention that, but negative 3, if I go back to my original problem, is not in our domain. So x cannot equal to negative 3. So if it doesn't exist there, you can't have a min or max. Okay, well, let's take the information we found and come up with our graph. Okay, so we got a vertical asymptote of negative 3. So we got a vertical asymptote of negative 3. We got a horizontal asymptote at y is equal to 1. X-intercept is at 4. Y-intercept is at negative 1 1/3. Maybe right there. It's increasing. Let me write down the intervals here. Increasing from negative infinity to negative 3. And it's also increasing from negative 3 to positive infinity. Okay, I come up here. If I were to draw my graph down in this little piece right here, it's going to skim this, it's going to skim this. But if I were to draw it down here, it has to cross our x-axis. And only x-intercept is over here. So that doesn't fit. Not to mention that, but it would be decreasing also. So increasing means it has to be up here. Now this other one's increasing. Again, if I put it here, it'd be decreasing, not to mention it would cross the y-axis, and I don't have any y-intercept up here. So it has to be down here, and it has to be passing through those two dots there to get something that looks like that right there. Now I could plot a few more points to get, or plot a few points to get a truer picture of what this looks like. But that's our rough sketch, and that's what I'm looking for here. Well, let's just compare it against what we see in the calculator. So again, the key to plugging in a rational into your calculator is parentheses around top, parentheses around the bottom. Anytime you have more than a single x or single number on top and bottom, you have to put parentheses around it. So let me come over here. I'll press y equals, clear, do a beginning parentheses, x minus 4, closing parentheses divided by beginning parentheses, x plus 3, closing parentheses, and then graph. And let's compare that against our graph. I'm not too far off. You know, it looks like it goes out a little bit more and so forth, and I could have been more precise, but again, we're just getting a rough sketch. There's a movie called Blues Brothers, and at one point John Belushi's trapped down in the sewer by a woman he's jilted, and he left her at the wedding and never showed up, and he's giving her excuse after excuse. That's what I should be giving you here. The sun was in my eyes. My tablet went. I guess you probably wouldn't buy it, would you? Okay. Let's look at this one. Numbers is 14. Okay, so we got y equals x minus 1 over x squared minus 7x plus 12. Same instructions. So let's first find our x-intercept. We'll grab a drink first. Okay, so for x-intercept, for the intercepts, you always plug 0 into the other variable. So plug 0 in for y. So we got 0 is equal to x minus 1 over x squared minus 7x plus 12. And again, whenever you have a rational and you set it equal to 0, it's very easy. You just set your top part equal to 0 for your intercepts, not for critical values. Then we'll solve for x, so we get x is equal to 1. And that's our x-intercept. Now for our y-intercept, we'll always plug 0 into the other variable, so we'll plug 0 in for x. So I got 0 minus 1 over 0 squared minus 7 times 0 plus 12. So we got y is equal to negative 1/12. Now I know approximately where that's at. I don't need to put that in decimal form. Vertical asymptotes. Now our steps say to factor the top, factor the bottom. And I can factor the bottom. It's x minus 3 times x minus 4. But that doesn't cancel with anything on the top. So I'm going to go ahead and skip straight to step 3. Set your denominator equal to 0 and solve. So we got x squared minus 7x plus 12 equal to 0. And that's x minus 3 times x minus 4. Zero factor property from college algebra. Set each factor equal to 0. And solve. And you get 3 and you get 4. And those are our vertical asymptotes. Now horizontal asymptotes. Degree of the top is 1, degree of the bottom is 2. So the degree of the bottom is larger. If the degree of the bottom is larger, then it's always y is equal to 0. Well, let's find our increasing, decreasing, and our extrema, our mins and maxes. So I use the quotient rule again. This will be P and this will be Q. P prime will be 1. Q prime will be 2x minus 7. So we have P prime Q minus P Q prime over Q squared. This one actually comes out very interesting. And we'll set aside this for our graph. Okay, so y prime, P prime was 1 times Q, which is x squared minus 7x plus 12, minus P, which was x minus 1, times Q prime, which was 2x minus 7, all over Q squared, so x squared minus 7x plus 12 squared. Let me double check myself there. P prime times Q minus P times q prime. That looks right. Now, normally we'd factor out something on the top that they have in common, but there's nothing they can have in common. I could factor the x squared minus 7x plus 12, but still nothing comes out. So I'm going to go ahead and multiply everything together, combine together like terms, see what happens. 1 times anything, the 1 drops away. So we've got x squared minus 7x plus 12 minus, and then multiply these together, x times 2x is 2x squared, x times negative 7 is negative 7x, negative 1 times 2x is negative 2x, and negative 1 times negative 7 is a positive 7. Oh. Bottom part remains as is. So up on top, I got x squared minus 7x plus 12, and minus 2x squared, negative 7x, negative 2x is negative 9x plus 7 over the bottom part. Okay. So up on top, I got x squared minus 7x plus 12. A negative in front of your parentheses flips the sign of everything inside, so it becomes a negative 2x squared plus 9x minus 7 over all this. Now we're going to combine together like terms. X squared minus 2x squared gives us negative x squared. Negative 7x plus 9x gives us positive 2x. 12 minus 7 gives us 5 over the denominator. And that's our first derivative. Let me double check here, make sure I didn't make a error of some sort. Okay, I'm kind of double checking myself as I go along, but it's so easy to add something wrong or subtract something wrong in these. Okay, so to find our critical values, we're going to set top part equal to 0, bottom part equal to 0. So I got negative x squared plus 2x plus 5 equal to 0. And I'll set the bottom part equal to 0. So I got x squared minus 7x plus 12 squared equal to 0. Now this doesn't factor, so I'm just going to use my graphing calculator to get this. We're going to put the polynomial on y1. So go to y equals clear. And negative x squared, so actually I should have cleared my buttons first. Okay, I go to y equals clear. Negative x squared plus 2x plus 5, and you have to have 0 on y2, so down arrow and put 0 on y2. Okay, now we're going to do a second trace, and we're going to choose intersect, number 5, and by choosing it I just press the number 5. Our answers are where it crosses the x-axis. This one looks like maybe negative 1. Now notice it says first curve, so I'll press enter on it. When it comes back and says second curve, press enter on that. And then for your guess, we'll put in negative 1. So actually type in negative 1 and push enter. And it wasn't negative 1, it was negative 1.4. Now, I know that that's not actually my answer. I could use the quadratic formula and get the square root version of it. There's really no benefit to that. Since we're graphing it, this is the one that's going to benefit me the most, because this tells me exactly where it's occurring at. And then our other one, let's find it. So we'll go through our process again. I'll do second trace, choose intersect, enter, and I'll put in 3, and we get 3.4. Again, I'm happy with the decimal, the 1 decimal place. Now over in this right side here, I can drop the squared. Whenever you have parentheses to a power equal to 0, you can always drop the power. So we got x squared minus 7x plus 12 equal to 0. This factors as x minus 3 times x minus 4. set each one of those equal to 0. So I set x minus 3 equal to 0 and x minus 4 equal to 0. And I get x equals 3 and x is equal to 4. So all these are critical values. Okay, so let me come over here and clear over here is negative infinity. And clear over here is going to be positive infinity. And 1, 2, 3, 4. There we go. See, our smallest one is negative 1.4. So negative 1.4. And the next one is 3. Then 3.4. And then 4. And again, he split these up into intervals. I want to pick test cases. I want to pick a test case between negative infinity and negative 1.4, maybe negative 2. Something between negative 1.4 and 3, like 0. Something between 3 and 3.4, like 3.1. Something between 3.4 and 4, like 3.5. And something greater than 4, like 5. Let me get a drink here. Now I want to plug these into our derivative. Our derivative is right here. That's our y prime. So we want to plug these into y prime. That's a lot of work. I don't want to work that hard. I'm going to go put this in my calculator. I'll put the derivative in the calculator is what I mean. So put parentheses on top and parentheses on the bottom. You actually don't need them around the bottom since you already have parentheses and then squared. That's considered one item. So now that I see that, let me get rid of those. Doesn't hurt to have them, so if you're not sure, go ahead and do it. Okay, so I'm going to press y equals clear, and I'll put a beginning parentheses, negative x squared plus 2x plus 5, closing parentheses divided by beginning parentheses x squared plus minus 7x, sorry, plus 12, closing parentheses, and then squared. Okay. Now we want to go into a table set, so I want to do second window, and let's make sure that we're set up here to for ask mode. You see where it says independent? Down arrow to that line, and right arrow, and if it isn't already highlighted, put your flashing cursor on the ask and press enter one time. Do a second mode to exit out. Now do second graph to go into your table mode. If you have any numbers there, you can delete them. You probably won't if this is your first time in this. Now let's put in negative 2. Let's put in 0, 3.1, 3.5, and 5. Okay, so I put negative 2 in, I got a negative, so this is decreasing. So that's decreasing. Now 0, I get a positive, so this is increasing. Which means we have a minimum here, which I'll come back to, but 3.1, 196.3, so that's increasing. For this one, what is it? 3.5, it's negative, so it's decreasing. And this one, if I remember right, yeah, is also decreasing. Okay, so this means this is decreasing and then increasing, so this is a min. This is increasing and then decreasing, so this is a max right here. And I say that because those values actually exist. So we're going to have a min at negative 1.4, and we'll have a max at 3.4. Well, what's the y value going to be? Well, let's plug it back into our original function. So let me scroll up here. Here's our original function. And I'm going to be lazy. I'm going to let the calculator do it for me. Again, I'm going to put the parentheses on top, parentheses on the bottom, and I'll plug them in. Okay, so I'm going to go to y equals, clear, put a beginning parentheses, x minus 1, closing parentheses divided by beginning parentheses, x squared minus 7x plus 12. Now if I wanted to work real hard, I could plug them in, but I don't want to work that hard. And we want to go into table mode, so I do second graph to go back in table mode. Now I still have these values, so I'm going to press delete to clear those out. Okay, so we said min of negative 1.4. So we type in negative 1.4, enter, and that gives us negative point, I'll take it to one decimal place, 1. And our max, 3.4. So 3.4, enter, and that gives us negative 10. And then we also have our increasing and decreasing information here. This is decreasing from negative infinity to negative 1.4. Then it's increasing from negative 1.4 to 3. And then it's increasing from 3 to 3.4. And then it's decreasing from 3.4 to 4. And then it's also decreasing from 4 to infinity. Okay, let's come up here. Start coming up with our graph. Vertical asymptotes at 3 and 4. And our x-intercept is at 1, so it crosses here. Our y-intercept is negative 1/2, which would be maybe right there. Okay. Our min is negative 1.4, negative 0.1. Negative 1.4. So right here, let's say, that's our min. Oops. And our max is 3.4, negative 10. 3.4, negative 10. That's negative 1. Let's say this is negative 10 here. So 3.4 would be right here, a max. Okay, well if this is a max, I know that what this part's going to look like. It's going to come up here, touch there, and go back down. So it'll look like that. Probably over here on the right side's easiest. So that's decreasing and then increasing. So that explains this and this. And this is decreasing from 4 to infinity. Decreasing. Well, if I put it down here, what was a horizontal asymptote? Horizontal asymptote is y is equal to 0. Okay, I knew we were missing something. So that's going like that. So it's, what did I say? 4 to infinity, it's decreasing. Well, if I put it down here, this would be increasing. So this has to be like that. So that's decreasing. Now over on this side, let's see what in the world's going on. Going up to the min, it's decreasing. But it's skirting this. So I'm guessing it's going like this. Reaching a min here, coming down here, touching that, going up like that. And then going up like that. Now let me see if that makes sense with the increasing and decreasing. Okay, so after the min, then it's increasing for a little bit, and then it's increasing again. Yeah, so it can't be going down. So that's our graph. Well, we actually have this already in our calculator, so let's just go ahead and press graph. And yeah, that I could have went down a little bit further here. I'd had to plot points to see it, but that's okay. And this part down here we really don't see. It's like a little dot right down here. That's the part that calculus gives you the true picture. What does it look like? Calculator will sometimes lie or mislead you because you can't see all of it. Sometimes it just lies. It gives you a graph that isn't true. So, well, let's save that. And then we'll look at our next problem. Okay, number 15. We got y is equal to x squared minus 4 over x plus 1. Same instructions. We want to graph it. Let me grab a drink real quick. Oh. So let's find our intercepts first. Let's go with the easy stuff. For the x-intercept, we'll plug 0 into the other variable, so we'll plug 0 in for y. So we got 0 is equal to x squared minus 4 over x plus 1. Again, rational is very nice. If you got a fraction equal to 0, you can just set the top part equal to 0, at least in terms of the intercepts. Take the negative 4 over, it becomes a positive 4. Drop the square root off and put a plus or minus square root around the other side. And square root of 4 is 2. So our x-intercept is plus or minus 2. Now our y-intercept. Always want to plug 0 into the other variables, so plug 0 in for x. So got y is equal to 0 squared minus 4 over 0 plus 1, which gives us negative 4 over 1, or y is equal to negative 4. Now for our vertical asymptotes. We'd normally factor the top, factor the bottom, cancel, but there's nothing to cancel. So we'll go directly to step 3, set the denominator equal to 0 and solve. So take the 1 over, it becomes a negative 1. And that's our vertical asymptote. For horizontal asymptote, degree of the top is larger than the bottom, so there is none. Okay, now let's find our increasing, decreasing, and mins and maxes to see if that can help us any. So we got y is equal to x squared minus 4 over x plus 1. Okay, so I'm going to let top be p and the bottom be q. So we need p prime, which would be 2x, and we need q prime, which would be 1. Our quotient rule is p prime q minus p q prime over q squared. P prime was 2x, q is x plus 1, minus p, which was x squared minus 4, times q prime, which is 1, all over q squared, which would be x plus 1 squared. And, okay. So there's nothing I can factor out of the top, so I'll go ahead and just multiply everything together and combine together like terms and so forth. So we've got 2x times x gives us 2x squared. 2x times 1 is 2x. Negative out in front of the parentheses flips the sign of everything inside, so it becomes a negative x squared plus 4 over x plus 1 squared. Double check that everything there. Yeah, looks good. Combine together like terms. 2x squared minus x squared is x squared plus 2x plus 4 over x plus 1 squared. And that's our derivative. Well, let's set top part equal to 0. So we've got x squared plus 2x plus 4 equal to 0. And we'll set the bottom part equal to 0. So x plus 1 squared equal to 0. Now I'm going to use a calculator to do this, just to show it again. It actually doesn't have a solution, but let's look at it. Press y equals clear x squared plus 2x plus 4 Now you have to have 0 on y2, so again, if you don't have 0 there, down arrow, put 0 there. Now we do second trace and choose intersect. Our answer is where it crosses the x-axis. Well, it doesn't cross the x-axis, does it? Which means this one doesn't have any answers. We'd come up with imaginary numbers if we did the quadratic formula. So we'll just look at the other one. Again, if you have parentheses to a power, you drop the power, assuming you have it equal to 0. And we'd get x is equal to -1. So that's our critical value. Okay, so here's negative infinity, and here's positive infinity. So this would be -2, and this would be 0. Picking test cases. Now we're going to plug them into our derivative here. This is pretty simple, so I'll go ahead and do it. We're going to plug them into x squared plus 2x plus 4 over x plus 1 squared. And then x squared plus 2x plus 4 over x plus 1 squared. Now, our critical value is -1. -1 doesn't exist up in our original problem. It's not in the domain. So it can't be a min or max, but we can have increasing and decreasing. That's what we're going to be looking at. That'll help us give us a little picture of the graph. If I plug in -2, I got -2 squared plus 2 times -2 plus 4. And anytime you square anything, it's always positive, so I don't need to plug it in the bottom part. And here I got 0 squared plus 2 times 0 plus 4 over a positive number. Well, -2 squared is 4. 4 plus 4 is 8. 2 times -2 is -4. 8 minus 4 is positive, so we got positive, positive, so this is increasing. 0 squared is 0. 2 times 0 is 0. Plus 4 is positive. Positive over positive is increasing. So it's increasing everywhere, except for -1, of course. Now that doesn't. It seems like, well, that doesn't tell us a whole lot. It actually tells us a lot. So let's see. Okay. Our intercepts are 2 and -2. So crosses here, crosses here. Y is equal to -4. Crosses here. Our vertical asymptote is at -1. So here's an invisible line that the graph will skim at some point. There is no horizontal asymptote. We said, what did we say? No memory. Increasing, increasing. So I know it's increasing. It has to be skimming this, so it's coming down like this, probably going off like that. And this is increasing, which means it's skimming down here. Oops. Didn't mean for that to be so abrupt. This is sketching, but so I didn't mean for that to be that bad. And then it's going off like that. Now I could plot points to verify that, but again, this is just sketching, so we're not going to spend a huge amount of time on it. If you want precision, you should be going to the calculator or to a computer program anyway. Okay, so graphing this on the calculator, again, you have to put parentheses around the top, parentheses around the bottom. Anytime you have a more than a single variable, a single number, you have to put parentheses around top and or bottom. So let's see what this looks like. See if we're even close. Y equals clear, beginning parentheses, x squared minus 4. Close parentheses divided by beginning parentheses x plus 1. Close parentheses and then graph. And not too far off. You know, again, we could have done points to get a little bit more precise, but not bad. So let me save it, and we'll be done with this section. Let me stop the recorders.